So today we are talking about chapter 1.5, which is called multiplication patterns. You should have this written down in your math journal already. Our learning goal today is by the end of math today, you need to be able to use multiplication facts and patterns to solve multiplication problems in your head mentally. Okay? So, this is a problem that's in your math book, but you're just going to look at it up here. Okay? It says, how close have you ever been to a bumblebee? The actual length of a queen bumblebee is about 20 millimeters. How long? Okay. This photograph right here shows part of a bee under a microscope at about 10 times its actual size. Okay, you can see right here, the bee is being magnified at about 10 times its actual size. What would be the length of a bee if it was magnified at 300 times its actual size? So let's figure it out. So how long is a bumblebee? Is a queen bumblebee with a quiet hand? Shreya? 20 millimeters. And if I want to find out how big it would be if I magnified it 300 times, what do I need to do to the 20? Misaki?
Times 300.
I need to multiply the 20 by 300. Now today we're going to look at how we can use our knowledge of math facts, of multiplication facts, and also math patterns to multiply this really quickly in our head. Okay? So let's break it down. If I had to break down 20 into 10 times something, what would it be? 10 times 2, okay? Now let's break down 300. 300 is 10 times what?
No, 100 times.
10, oh, it's 100 times 3, so how can I break 100 into 10 times something?
Oh, you can do 10 times 3.
10 times 10 times 3. Is that true?
Yes.
Okay, so let's first take our two numbers that are not 10. 2 and 3. Can we really quickly multiply that in our head? 2 times 3 is? 6. Okay, so I have 6 times 10. Is 10 being repeated a lot?
Yeah.
How many times is it being repeated? 1, 2, 3. So my base number is 10. What would the exponent be? Liam? 3. So using the way the book calls it, is 20 times 30 the same thing as 6 times the third power of 10? Okay, can we quickly multiply this? What is the third power of 10? 1,000. How can we use a pattern to know that the third power of 10 is 1,000? Daniel.
You do 6 times 10, 10 to the 0 power.
Okay.
6 times 1.
What pattern did we notice yesterday with zeros and exponents? What pattern did we notice yesterday with zeros and exponents? So we know that the third power of 10 is 1,000, so we have to multiply that by 6. What's 6 times 1,000? 6,000. So our answer to the problem, it says, what would the length of a bee appear to be at a magnification of 300 times its actual size? 6,000, what's the label? Stuart? Millimeters. Good. So our answer is 6,000 millimeters. Let's try this one. Multiply 50 times 8,000. Remember, the first thing you should be doing right now is writing this problem down in your math notebook. Everything you see up here, you're writing down. 50 times 8,000. Okay, let's break this down into the factors. 50 is the same as 10 times what? 10 times Ariel? 5. Thank you. Okay, we want to always break it down by 10. So 8,000 is 10 times what? 10 times Liam?
10 times 10 times 10 times 8.
Do we agree that 8,000 is 10 times 10 times 10 times 8?
Yep.
Okay, let's look at first our non-10 factors. Okay, what do we have? 5 times 8, okay. And then we have times, do we have 10 as a repeated factor here? If 10 is the repeated factor, does that make 10 the base or the exponent? Siddharth? If 10 is the repeated factor, it makes it the base. So I have 10 as the base. And what should my exponent be? Remember, the exponent tells us how many times the base is multiplied. So let's see, Karan, how many times is the base of 10 multiplied? 1, 2, 3. Is that correct? Oh, 1, 2, 3, 4. So my exponent should be 4. Okay. So now let's tackle this part first. 5 times 8 is what, Neha? 40. Okay, so I have 40 times the fourth power of 10. Using what we know about patterns, if the exponent is 4, how many zeros do we expect the fourth power of 10 to have? Show me with your fingers. All right, I'm seeing lots of 4s. If 4 is the exponent, then the fourth power of 10 should have 4 zeros. So that's 1, 0. Does it have 4 zeros? So then my multiplication problem becomes 40 times 10,000. Can we quickly do that? Okay, so what's 40 times 10,000? 400,000. Be careful with those zeros. So what is 50 times 8,000? 400,000. And if we want to write it as an exponent, we could do 40 times the fourth power of 10. Make sense? Could we rewrite 40 times the fourth power of 10 in a different way too? Could we say that 40 equals 4 times 10? Is 40 4 times 10? Is this the same base number as what we have over here? So could I also write this as 4 times 10, the fifth power of 10? Because I have one more 10 in the equation. Does that make sense? Good. Okay, now let's use mental math to complete the pattern. 6 times 4 is? 6 times 4 is, with a quiet hand, Ashi? 24. Okay. Now we have 6 times 4, which we already know is 24, times 10 to the first power. What's 10 to the first power of 10? What is that?
10.
Adam, thank you for your quiet hand. 10. What's 24 times 10? Adriana?
24 times 10 is 2,400.
200, 400?
No. It's 240.
Ah, 240. Oops. Oh well. Sorry, guys. Hold on one second. I'll just cross it out. So 224 times 10 is 240. Okay. Now we know that 6 times 4 is what already? 24 times the second power of 10. What's the second power of 10? Tanvi?
20. Oh, sorry about that. I mean
100. 24 times 100 is? Soham? 2,400. Okay. 6 times 4 we already know is, Marcus? 6 times 4 is? 24. And now it says times the third power of 10, which is? 1,000. So 24 times 1,000 is, Misaki? 24,000. What pattern are you noticing here?